Hi, my name is Arish. Today I will talk about regression analysis on ArcGIS. What type of analysis can we perform on ArcGIS? Specifically, we will see how can we use special statistical tools for a particular dataset. If you find any queries after watching this video, leave a comment down below. I will check them out later. I have divided this video into three parts. What is regression analysis? How many types of regression analysis? Which tools can be used for regression analysis on ArcGIS? Regression analysis is a set of statistical methods used to estimate relationship between a dependent variable and one or more independent variable. It can be utilized to assess the strength of relationship between variables and for modeling the future relationship between them. This is the generalized equation that can be used for regression analysis. Here y indicates the dependent variable, beta naught and beta 1 indicates the y-intercept and slope coefficient, x is the independent variable and ellipse is the random error term. Correlation is the statistical measurement of relationship between two variables. A correlation exists between two variables when one of them is related to the other in some way. A scatter plot is the best place to start. The closer the point lie to the straight line on a scatter plot, the stronger the linear relationship between two variables. To quantify the strength of the relationship, we can calculate the correlation coefficient called Pearson correlation coefficient. I am not going in the details of the Pearson correlation coefficient and how to calculate it. This first plot shows the strong positive correlation, then there is a weak positive correlation. If the line goes down, then there is a strong negative correlation. Beyond this plot, there is a weak negative correlation and a moderate one. And then there will be no correlation found if the correlation statistic does not indicate the relationship between two variables. Regression analysis includes several variations such as linear, multiple linear, and non-linear. The most common models are simple linear and multiple linear. Non-linear regression analysis is commonly called for complicated datasets in which dependent and independent variable shows a non-linear relationship. When there is a single independent variable used, then it is referred to as a linear regression. When more than one independent variable used in the model, then it is called as multiple regression. And the non-linear regression when there is no linear trend found in the model. Now the tools used for the regression analysis on ArcGIS. The first one is the ordinary least squares and the second one is geographically weighted regression. I am not going into the detail what's the difference between these two models. I will make another video on this topic. Then I will explain in that video. Let's jump to the software for making our first model. So I have a dataset of precipitation, temperature maximum, temperature minimum for the month of December 2018 and I am going to go ahead and add this data now. Alright, here I need to extract it according to the specific location. For this video, I will do the regression analysis for all the cities of Pakistan. Let's add the shapefile of Pakistan. Now we need to extract it by mask because we need the data only for this country. Go to the search bar and write over here extract by mask. Add the input raster file, add the mask data, go to the environments, processing extent, set it as same as layer Pakistan cities. Here we go. Now repeat the same process for other two TIFF files. Now we can remove these TIFF files. Here we need to convert this raster file into points. For this purpose, we need to use the conversion tools raster to points. Just search it here as raster to point. Input the raster file. For the other two TIFF files, we use another tool, extract multi-values to point. You can find this tool by the search. Double click on it and add the input features, add the remaining TIFF files and press OK. Now open the attribute table, and grid code means this is the precipitation data, and this is the temperature maximum for the month of December 2018 and temperature minimum for the month of December 2018. We can change the name from properties now. You can see there are a lot of points for this whole country, and these total points is 53,000, and we are not going to use as it is. So what we need is, if we have one point for each polygon, it will be good for understanding as well as regression analysis. So we can do this by joining special feature based on location. Just right click on this shapefile and go to the join and relates and click this join. You need to select this join data from another layer based on special location, and the data is already selected. What we need is, we need to take the average of all the points within the polygon and click OK. Now you can see the data in the join output shapefile. Our data is converted into 1 point for each polygon, and you can see this is the average grid C. This is the actually precipitation data, and this is the average temperature maximum, average temperature minimum. Now this data can be used for regression analysis. Now just go to the search toolbar and search it here as OLS. We need to add the input feature class, unique field ID, and dependent variable would be average grid C, and explanatory variable would be average temperature maximum and average temperature minimum. You can give the location of output file, report file, and hit OK. For seeing the results, you can click on geoprocessing and click on the results, but you can see I have added this result toolbar here. Just click on this latest session, open the messages. Here you can see the results of OLS. This is the summary of the results: average temperature maximum, average temperature minimum, what would be the intercept value, and what our the standard deviation error, statistics, probability, and this is our mean adjusted R square value 0.56. For changing the color ramp, you can go to the properties and select your desired color ramp. For making the graph between the estimated and observed rainfall, you just need to open the attribute table and select the table options. Go to the create graph, set the graph type as scattered plot, set the y field as estimated and x field as average grid C, because average grid C is our observed rainfall. Set the title as observed predicted and click on finish. So this is the our graph between the observed and predicted, and our R square is the 54%. It means if we add other variables like sunshine hours and relative humidity, so our R square would be improved. So just close it here and go to the layout tab. I am going to change this layout from here, and I am selecting this layout. For adding the graph in this layout, go to the view and select the manage graph and add to the layout. So this is our graph. I want to change the theme. For changing the theme, we can go to the advanced properties, click on themes, and I am going to choose facts and click on apply and close it. For changing insights, go to the properties, set the width as 200. Now it seems somehow visible. Now it is looking good. For adding the legend, click on insert, go to the legends, remove the remaining ones you don't want to add, click on next. I am going with the default setting, next and finish. For adding the title, click on insert and add the title here. Click OK. Now we can add the north arrow bar. So our layout is completed for ordinary leaf scale. We can export this map here by this option. Set your desired name. And click on save. Now go to the graphical weighted regression. Go to the search toolbar. Add the input feature. Our dependent variable would be average grade C. An explanatory variable would be average temperature minimum and maximum. Set the kernel type as fixed and go to the default option. So this is our graphically weighted regression method. For results, go to the results tab and open the messages. Here our R square value is 0.70. It means our explanatory variables explaining the 70% the precipitation data. Now close this toolbox. For changing the color ramp, you can go to the properties, set the desired color ramp, and click on apply. So for making the graph, go to the attribute table and select this create graph option. Select the graph type as scattered plot, set the y field as predicted, and click on next. And click on finish. So this is the graph for graphically weighted regression. We can add it on our layout later and close this window. Now adding the 3D effect on this layout, we can add the hillshade to this map. Go to the search toolbar and search hillshade. Add the input transfer file as precipitation and click OK. Now uncheck these layers and change the order of this hillshade. Now adding the transparency to this hillshade effect. Set the transparency as 85%. Click on apply and hit OK. It gives our 3D look to this map. Now go to the layout view. Change its title from their properties. Set the legend by going to the properties. And click on apply. Change their font size so it can be visible. Now adding the graph by going to the manage graphs. Now adding the graph by going to the manage graphs. Add to the layout. Go to the advanced properties. Set the themes as facts and click on apply. Set the graph size by going to the properties. Now we will add the R square value by text option. Go to the properties and change the font and increase the font up to 28. Now we can export this map. and click on save. So this is our final result for geographically weighted regression. If you find this video helpful, please subscribe this channel and thanks for watching.